what we're going to do with the sum and difference formulas now is use our ratios to help find the sum or difference. Okay? And I'm going to caution you here. These are pretty tough. Okay? Some of them aren't really that bad because you get nice numbers. But what really makes them tough is not the trig. It's all the algebra and the radicals and then the fractions. Okay? So you have to pay really, really close attention because some of us are lacking in the radicals and fractions. Okay? Now, let's look at this one. Okay? And really, if you want to kind of compare it here on your sum and differences sheet, it's kind of like number 57 you can get after we get to work. Number 57 after we do this one. Okay? Now, it's sort of a three-part problem, and these things, they take forever to get through one problem. Right? You need like a page to do a whole problem because you're finding three things. Okay? It says find the exact values of the expression of the cosine of alpha plus beta, the sine of alpha plus beta, and the tangent of alpha plus beta. Okay? So we're going to use the formulas. Now, we haven't seen them that way before, have we? Okay? I've probably showed you the alpha variable before. All right, but that other one, I call it B with a tail. Okay, that's beta. All right, so what have we been using instead of alpha and beta? A and B. Okay, but it's the same thing, right? Okay. So instead of A, we're just replacing it with alpha. All right, instead of B, we're just replacing it with beta. So let's do this. You probably just watch this one. I think you'll be okay with it here. But I'm going to leave some space here, and you'll kind of see why in just a second. So let's start off with the first one. We're going to find the cosine of alpha plus beta from all this information that they're telling me here and here. Okay? So I'm going to see if you can figure out how we're going to gather up all that information. Now, I'm going to do the cosine of alpha plus beta. I'm going to put the formula in here. So I'll copy it off my formulas from here. So the cosine of alpha plus beta would be cosine alpha times cosine beta minus sine alpha sine beta. Okay. Now, let's see if we can fill that information in.
Do you have to memorize this?
Yeah. You already have the formula. Okay? Now, you don't have the cosine of alpha plus beta, but what could I use to get that?
A.
Cosine of A plus B. Same thing. Do what now? Yeah. So you can see why I skipped space in just a second. So maybe you can figure it out. Now, notice that they give us the sine of alpha. So I can put right here 15 over 7. And we'll do that. Now, also I have the sine of beta. Okay? The sine of beta is also 15 over 17. Okay? So I've got that one there too. Right? But how am I going to find the cosine of alpha and the cosine of beta? Alright, so yeah, it's got something to do with the quadrants. There you go. We're going to do it by doing a triangle. Okay. Because what's the cosine ratio? Adjacent over hypotenuse on a right triangle. Okay. So we're going to draw right triangles in these quadrants to help find the parts of the formula that I don't know. Okay. So that's one of the big keys in this is you have to draw triangles. Now, here's the thing. You have two angles. You have alpha in quadrant 1, and you have beta in quadrant 2. So it's not just a triangle. It's going to be two triangles. So I'm going to have an alpha triangle and a beta triangle. So it's in the alpha triangle. The angle alpha lies in quadrant 1. So let's draw a triangle in quadrant 1. I'll be sure to label it alpha because I don't want to get my two triangles confused. Okay, the alpha triangle. Now, it tells me the sine of alpha is 15 over 17. Now, how do we say the sine ratio? Right, opposite over hypotenuse. So that would be 15, that would be 17. Now, we're probably going to do that bottom side. Okay. So by the Pythagorean theorem, okay, we can say 17 squared minus 15 squared. So 17 squared would be 289. 15 squared would be 225. 289 minus 225 is 64. And so the square root would be 8. Y'all check me out. Oh, I'm awesome. That's pretty good. I did it again. Now, realistically, you would do that probably on the calculator. Okay? You just went in 17 squared minus 15 squared. That would give you 64. And so where's 8 coming from? You got to take the square root of it. Okay, so the Pythagorean theorem. If you need to do the equation out, you can do that too. Now, this is actually a nice problem because this is what's called a nice triple. Remember what we talked about triples were? The three sides of triangles are nice numbers. These get incredibly nasty when you get one of these that's not a triple. Okay? Because when it's not a triple, you get a radical. No, these bad. Okay? Now, let's do the beta triangle. All right, beta triangle's a little bit different. Beta triangle, how's it different? You have a negative somewhere because you're in quadrant 2. So anytime you're in the second or the third or the fourth quadrant, you're going to have negatives floating around, and you've got to be extra careful. Okay? Now, the sine there was also 15 over 17. So that's what opposite over hypotenuse. So this would be 15. Hypotenuse is 17. Same numbers. But yeah, this one would be not 8, but negative 8. How's it negative 8? Right, it's going to the left. Very good.
Why is it? Oh, you don't okay.
Right. So now you understand we have to have two triangles. Now we can go through this formula and fill everything in.
Yeah.
Okay. Now it's kind of helpful. You don't have to do this, but it is kind of helpful to list out the information to put in. Okay. So they told me this. They told me the sine of alpha was 15 over 17. The other thing that I'm going to need is going to be the cosine of alpha. You won't need the tangent or the other 3 or 4. Okay. So what would the cosine of alpha be here? 8 over 17. Where am I getting that from? Cosine is what? Adjacent over hypotenuse. See? Adjacent over hypotenuse. Now, over there on my other triangle, okay, they told me the sine of beta was 15 over 7. Okay. Now, we're going to need the cosine later. Right? What's the cosine of beta? Negative 8 over 6. Okay? Now, so to find the cosine of alpha plus beta, all I got to do here is just fill in my formula. Okay? I'm not filling in. Notice I'm not finding out what alpha and beta are. So we're not trying to find the angle. We're trying to find the sum, or the cosine of the sum of the angles. So the cosine sum formula. Okay? Now let's fill this in. So, right, what's this part here? What's cosine of alpha? 8 over 17. Okay. Alright, cosine of beta is negative 8 over 17 minus, right, the sine of alpha, which was 15 over 17, and then the sine of beta was also 15 over 17. Okay. It's kind of rare that they actually work out to be the same like this. Now, let's multiply this out. So notice we're going to multiply before we add or subtract. So let's multiply this out. What's 8 over 17 times negative 8 over 17? And don't use your calculator. Okay. Negative 64. Now 17 times 17, I'll let you use your calculator. That's 289. Okay. Now, I'm not sure if that's going to reduce or not. But one thing that I'm going to stay away from is not reducing that fraction. You don't want to reduce that fraction, and I'll show you why in just a second. and it's going to be minus 15 over 17 from 15 over 17 will be 225 over 289. Now, can you see maybe why I'm going to caution you against reducing? Right, they're the same denominator, aren't they? Okay, so I want the denominator to be the same, though.
Right.
And if that reduced, then it wouldn't be the same anymore. So you can reduce the fractions, but don't reduce them there. Reduce them at the end of the problem. Okay, so you can keep that common denominator. Now, when we subtract that denominator is going to stay the same, isn't it? It's going to be 289. So now all I have to do is negative 64 minus 225, which is negative 289. Okay, so notice what this comes out to be there. Negative 1. A lot of times it comes out to be just a fraction. Sometimes not very nice. Now, that was the cosine of alpha plus beta. All right, what else did it ask me to find? The sine of alpha plus beta. Okay? Now look. See? So the cosine of alpha plus beta. Now I'm going to find the sine of alpha plus beta.
So I think for that, are you the same as some difference when you're using alpha and beta?
Right. 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 Okay. So all we're going to have to do is just plug in to the sine of alpha plus beta formula. Okay. So let's write down the alpha plus beta formula. Okay. The sine of alpha plus beta is equal to. Might get y'all to help me out. It starts out with what? Sine alpha, cosine beta. Is that right? Right. Plus what? Cosine alpha, sine beta. You don't have to memorize it. Just look at the sine of a plus b on your formula sheet or over there on the board. Okay. Now let's fill this in. Now we've already found from our two triangles what the sine of alpha is, what the cosine of beta is, the cosine of alpha, and the sine of beta. All we got to do is fill it in. So let me scroll back up to the top. All right. So tell me, what's the sine of alpha? 15 over 17. See how it's beneficial to write them down now? Instead of looking at the triangle, trying to figure it out every time you write them down, it's quicker. So 15 over 17. Okay. Now, cosine of beta, so back up. And negative 8 over 17. No. Not every. It was coincidental because the two triangles were so similar. All right, plus, all right, cosine of alpha. Cosine of alpha. Yeah, 8 over 17. See it right there? Okay, times the sine of beta. What's the sine of beta? 15 over 17. Okay. Now, we multiply before we add there, right? Now help me out. What's 15 times negative 8? Negative 120? Okay. Negative 120 over 17 plus. Alright, this one would just give me 120. Oh, I'm sorry. I messed up. Yeah, that would be over 289. I didn't multiply my 17s there. What was I probably thinking about when I did that? I was thinking about adding. And when I wasn't adding, I was multiplying. Okay, that's a mistake a lot of people are going to make. Now, this just is going to turn out to be 0. Okay. So negative 120 plus 120 is 0, and then 0 over 289 is going to be 0. Okay. Now, so there's part B. Okay. Now, we got to do the tangent of alpha plus beta. Now, you could do what the formula for tangent of alpha plus beta, or let's just do sine over cosine, because we already found sine and cosine, didn't we? Okay. So we won't use the tangent sum formula. Instead of the tangent of alpha plus beta from the sum or difference formula, we're going to do what? The sine of alpha plus beta over the cosine of alpha plus beta. Okay. So what was the sine of alpha plus beta? We just found it. 0. Okay. And then the cosine of alpha plus beta, it really doesn't matter, but it would be -1. And then 0 over -1 would just be 0. Okay. Now, imagine how fun this gets when one of these numbers ends up being a radical. Yeah, it gets nasty. Okay? Now, let's do this. Let's start with an easy one. Okay, this is why we're doing this like across 2 days. Y'all look at the very first one in the assignment. Okay, y'all try number 57. I'm gonna write it out here.
You throw like out of tangent.
Sure.
I'm not lazy. I'm not.
Alright, now, some of these are kind of hard to read because the equal signs look like negatives. Can you tell the difference between the equal sign and the negative? Like on 57, sine of alpha, that's not -3/5. That says sine of alpha equals 3/5. The sine of beta equals 5/13. Okay. So now, how do we need to start this off? Do we just start throwing stuff in the sine of, or the cosine of alpha plus beta
No,
formula?
depending on where it's sitting.
Okay. So can I start here, just throwing stuff in? I'm going to put them in the right spot. Okay. What was, I'm going to be smart. Paste this. I need to copy and paste. All right. Now, so we can just start throwing numbers in there. Well, where are we going to get the numbers from? Triangle. All right. So draw your triangles out, and I'm going to come behind you and draw the triangle. Yes. Go ahead.
On 57 through 64, it say 8 plus beta. So just automatically put whatever the sign is.
Well, we got to find those values for our triangle.
No, okay. On our paper, it say 8 plus beta instead of that plus beta.
No, it says alpha plus beta. That's alpha. That's a little fishy. Okay. That's not A, that's alpha. Okay? But, I mean, it really doesn't matter, right? It's A and B. Okay? They're just using fancy variables. Okay? I think they're better than us. Alright, come on, gotta do it. Number 57. You gotta do it anyway.
Ourselves, cosine, or
I'm gonna work it behind you. Alright, you got 2 triangles drawn out and solved?
No.
Hurry up. I like the word. I don't like to sit down. Yeah.
You always have to do alpha graph.
You don't have to. But, you know, it's always going to be given charts and problems. So. Alright, first triangle was in quadrant 1. Now once you get the triangles drawn and filled out, stop. Okay? Don't get too far ahead. I want you to get too far ahead in this. Alright, beta triangle was in what quadrant? Where's the beta angle? Yeah, same quadrant. Now, it's really important that you label alpha and beta. Otherwise, you know, if you goof up one little thing there, hang it up. You're not going to get it. So be sure you label this. You do this just like I tell you here. Don't go all cowboy on me and try to do it on your own. Okay? Do it the way I showed you. Don't deviate. Now, what did it say about the alpha triangle? The sine and the cosine was what? Sine was 3/5. Alright, sine is opposite over hypotenuse. So, y'all put 3 here and 5 here.
Yes.
And then right here is 4. Question. Okay, other triangle is in quadrant 2. This time they said the sine was 5 over 13. So again, sine is opposite over hypotenuse, so this would be 5, 13. By Pythagorean theorem, this would be 12, but it's negative. Okay. Now, guys, I tell you, the thing that people miss most on these problems is they forget the negative signs. Okay? If you're in the second, the third, or the fourth quadrant, you're going to have some negatives. In the third quadrant, both legs are going to be negative. Because you're going left and right. Alright? And like in the fourth quadrant, your up and down leg will be negative. And now, alright, you want to write out now over here what the sine and the cosine of alpha was? Now do that real quick and I'll check.
Sine of alpha is 4 over 5.
Alright.
And the cosine of alpha is 4/5.
Alright, is she right there?
Yes.
Wait a minute.
No,
I did something else. The sine would be 3/5.
Don't say it wrong. I'm sorry. Paper gave us up.
Did you write it down right?
Yeah, I wrote it down right.
So we're getting what sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So really, it's really important to be really careful because you know you miss one little detail here, you're going to just miss it. Okay? It's going to suck to work all this huge problem and just miss it because I missed a negative sign or I didn't write it ratio. Now, let's do sine of beta and cosine of beta.
Sine of beta is 5 over 13.
Right.
Cosine of beta is negative 12 over 13.
All right. Log with that. Not making differences. Really, because we're gonna have to plug it in that formula. And so instead of like going up and looking at the triangle every time to figure out a sine or a cosine, now we'll just look at those. So we're not really looking at the triangle anymore. All we're now is going to be looking at these 4 little equations right here and figuring out where to put them in my formula. Okay. Now, all right, you guys take those 4 numbers, all right, put them in that formula.
Oh, most of the time you gotta have a common denominator, right?
When we add and subtract, we gotta have the common. So when we're multiplying, we're just going to multiply the denominator. And after you do that, you end up having a common denominator every time. And it works out every time. Right. So get a ratio there. You got that?
The alpha.
All right. Tell me what you got. Yeah.
I got negative 63 over 65.
Very good.
No, I didn't get that.
Alright, so negative 63 over 65 is what you've got. Now let's look at it. If you missed it, then just find a mistake. Okay? So let's plug them in. Cosine of alpha right there is 4/5. Cosine of beta, what's that one, DG?
That was negative 12 over 5.
Right. Alright, sine of alpha, what's that one?
Sine of alpha is
3/5.
Sine of beta is 5 over 13.
Yeah, sine of beta, 5 over 13. Now we multiply before we subtract, right? Okay. So let's multiply 4/5.
Oh.
This would be negative 48 over 5 times 13 would be 65.
I didn't multiply negative 12.
Now, I'm not sure if that reduces or not, but I am not going to reduce that because if I reduce it, I'll screw up on the denominator that I'm already going to have. Because notice over here, you get the same two numbers multiplying every time right there, don't you? So that gives you 65, gives you your common denominator. What's the numerator there going to be? 15, but we're going to subtract it. So negative 48 minus 15 gives you negative 63. Okay, what do I do with the denominators? Just keep them the same. Okay, so there's your cosine. Right, now, let's do the sine. Go ahead and start writing out your sine for me. Start writing mine out real quick. Man, look how fast they're open. Now, fill it in. I don't care what you get. Okay, it's right.
So the answer was that was negative 33.
You come out for part A. That's my answer for part A. And you see it's negative 48 minus 15. Okay. So you looks like you just did like 48 minus 15. That's it. Alright, tell me what you got. That's right. Okay. It's a negative 16 over 65. Alright, do I need to work that out for y'all? Did everybody get negative 16 over 65? Okay. Now, as long as you get sine and cosine right, you're probably not going to miss the tangent. Because on the tangent, we're going to take our shortcut, right? We're going to do the sine over the cosine. Watch how nice it'll work out. The sine was what? 16 over 65. And the cosine was negative 63 over 65. Right, so when I multiply by the reciprocal, the 65s are just going to cancel out. Right, the negative would just give me a positive, so all I'm left with would just be 16 over 63. Yeah. Okay. Now, you'll notice you're not going to be doing them for homework. Okay? Take some time. Now I am going to ask you to do this. I know I have no homework written up there, but I do want you to complete number 58. Okay? And don't work on it now because we need to get to the ones that are more challenging. Let's look. Alright, I'm going to do number 59. Okay, so leave a page to do 58. So by the way, these take about a page to do a piece. Okay. Alright. I think there's one that I'm gonna like let you go on because it's so bad. Christine, what was the one I had marked out in the paper? Alright, 62, you're gonna have to worry about 62. So mark out some.
what I was on? 62.
Alright, so get 59. Now I've got the information copied. Alright, let's get our two triangles. Now, I want you to work this one with me. You can get ahead of me if you want to a little bit. Alright, so my alpha triangle is going to be in quadrant 2. A little fishy there. Alright, the tangent is negative 3/4. Right, tangent is what? Opposite over adjacent. Now, I'm just going to put 3 and 4 there because that negative could be on the 3 or the 4. It would be on the 4, wouldn't it? Because the 4 goes left and the 3 goes up. The 3 would be positive and the 4 would be negative. Alright, now this one's pretty easy. What's the hypotenuse?
5.
5. Okay. Now the other one's not going to be as nice. Okay? And I'm just not looking forward to this. I actually love it. Alright, here we go. Quadrant 1. Alright, we've got our beta. And beta's just be with the tail hand now. Alright, the cosine of beta is 1/3. Right? Cosine is adjacent over hypotenuse. So this side would be 1, and the hypotenuse is going to be 3. Alright. Now, here's where we kind of start breaking down and start crying. So I'm just not going to do the crying. No, we're not going to do that. Okay. We'll be strong. This will knock the sucker out. Bring it on. Alright, so what's the other leg? What's it going to be? So what 3 squared would be 9, minus 1 squared would be 8, so it would be square root of 8, which is 2 square roots of 2. Okay, you introduce a radical, it gets pretty bad. Now, alright, double check your sign. Okay, all my signs right. In the first quadrant, you don't have to worry about it because everything's positive, right? But in those other quadrants, double check your signs. Double check. So that one's negative, that one's positive, so that's okay. Now, let's do this. Let's do our formulas here. Okay, are y'all want to list out the sine and cosines first?
Yeah.
I probably should do that. All right, so sine of alpha will be 3/5. Cosine of alpha will be negative 4/5. Right, on my beta triangle, sine of beta would be what? 2 squared is 2 over 3. And cosine of beta would be 1/3. Okay. That joker right there is going to make it pretty difficult. Alright. Now, let me hang on. Alright, let's find cosine of alpha plus beta. The rest. Okay, so let's fill it in. Cosine of alpha. Right. Cosine of beta. Okay. Sine of alpha. Yes. And then sine of beta. 2 square root of 2 over 3. Alright, well, let's see. Let's multiply first and then we'll subtract. Alright, so multiply this. This is going to give me what right there? Over 15 minus. Now, yeah, 6 squared is 2 over 15. Right? And look, I don't know how to say this nicely, but if you can't multiply radicals and whole numbers by now, well, I'm sorry. Now, what can I do here? Can I do negative 4 minus 16 and get negative 10? No. Okay. we can put them, what, all over 15. What's the deal with adding and subtracting radicals? Right, the radicand has to be the same. Okay, so if I had negative 4 square root of 2 minus 6 square root of 2, that would be negative 10 square root of 2. Okay, but I really can't combine those. Okay, so I can write both of it over 15 as the common denominator. Okay. All right, so isn't that a lovely number? Okay, now let's do the sine. Wait right after sine for me. I'm gonna write mine out too. See how fast I am? My fan's like a flat. Alright, so let's see, what's sine of alpha? Read that out. Sine of alpha is 3/5. I'm just going to let y'all call it out to me instead of spelling it.
3/5 times 1/3.
Cosine beta is 1/3.
Plus negative 4 over 5. And
Sine of beta,
2 over 3 over 3.
2 squared over 3. Somehow we could leave that one out. Okay, now double check this. You right there.
You was done with cosine?
Do what now?
You was done with cosine?
Yes.
Oh.
I can't. What I really can't subtract negative 4 minus 6. Yeah. So this is part A. This is my cosine. Okay. All right. Now let's multiply this out. This is going to give me 3 over 15. And I'm not going to reduce that, am I? Even though I can. That's 1/5. But I'm not going to reduce it. Because I'm not going to be able to put it over as a common denominator, right? That would be negative 8 square root of 2 over 15. Now, let's write all of that over 15. So 3 is 8 square root of 2 over 15. Okay. And now, we're not going to split it up and reduce it. And I can't reduce that, can I? Now I can't. Because you can't reduce the 8. Not to mention I don't want to do it anyway, because I want these numbers to be the same number for my tangent. Okay? Let's do the tangent. Tangent of alpha plus beta. Alright, we're going to do the sine over the cosine. Alright, the sine was that, right? So 3 minus 8 squared root of 2 over 15. Alright, what was the cosine? Negative 4 minus 6 squared root of 2 over 15. 4 minus 6 squared root of 2 over 15. Alright, 15 is going to cancel. 3 minus 8 squared root of 2 over negative 4 minus 6 squared root of 2. And we're just overjoyed because we're going to have to do what now? Rationalize. See, I told you wouldn't like that radical. Okay? And that's what the radical really messes it up. You have to rationalize. Now, no, because the operation is not multiplication. And now we can factor out a square root of 2 on both of them to do that.
We have to conjugate or whatever.
Yeah, we're going to have to do conjugate. Now, what are we going to do for on our test so we can get partial credit? Right, because I'm going to give you half credit. You can give me the unrationalized version correct. Okay. Now, let's rationalize. Oh, yes, rationalizing.
This is ridiculous.
I told you they'd be next. No. So on the conjugate, only the middle sign. So it's going to be negative 4 plus 6 squared root of 2. Do the same thing on the numerator. Right. Go here. Pull it on the top. Just first and last on the bottom. Alright, so help me pull it out. First, negative 12. Okay. And then
4 is 16.
times.
I'm sorry.
That's okay. All right, and then 3 times 6 squared root of 2 would be 18 squared root of 2. All right, negative 8 squared root of 2 times negative 4 would be positive 32 squared root of 2.
Oh my God.
Did y'all follow that?
No.
No?
No, I'm just kidding.
All right, now listen to me on the last part. Put your pencil down and listen to me, okay? When you multiply, especially something like this, okay, go ahead and multiply the negative 8 and the 6 minutes. That will give you what? Negative 48. And then the square root of 2 times the square root of 2 would just be 2. So it would be negative 48 times 2, which you can put in your calculator real quick. Negative 96. All right, now, do I need to go through that again? Now, on the denominator, all we have to do is just first and last. Okay, so first is going to give me 16. Now, last is going to be negative. Now, think about it. 6 times 6 is 36 times 2, which would be 72. Alright, let's clean this up. Negative 12 and negative 96 would be negative 108. 18 square root of 2 plus 32 square root of 2 would be 50 square root of 2. Alright, and now 16 minus 72, do that. Alright, now, right, we'll get rid of the negative denominator. There's something else though here too. You can reduce by at least 2. Okay. So you'll do it by negative 2 and take care of the negative in the denominator at the same time. So reducing by negative 2, this will give you positive 54 and what? And negative 25 square root of 2 over, what's 56? Maybe 65 by negative 2. 28 would be positive 28. Three years later, we'll understand. Yeah, I told you. Now, we'll do this one tomorrow. Alright, so do this. You need to do number 58 for me. Go ahead and try. No, I told you to do 58. Try to do number 60 for me too. Okay. Try number 58, 60 for homework. The rest of it, I'm going to let you in class tonight. Okay.